Here's something we all take for granted. Liquid things flow like liquids, and solid things flow like, well, solid things don't flow, right? Not so fast.
Glaciers are cool, and not just because they're made of ice. I'm here at Mendenhall Glacier, which is one of about 40 glaciers in the Juneau ice field. Glaciers are cool because the way that they move, even the very fact that they move, seems to defy physics. It's a solid that flows like a liquid. How? That is a question of glacial proportions.
To figure out how a glacier moves, first let's go back to the beginning. Not that beginning. The beginning of the glacier. And first, we've got to get up there.
I'm super excited. I've never been in a helicopter before, and we're gonna take this thing up to the top of a glacier.
This ice is born in the ocean. Warm, moist air from the Pacific rises up coastal mountains where it cools, condenses, and falls as snow and rain. 30 meters of snow, sometimes more, falls in this ice field every year.
You need more than a mountain of snow to make a glacier. You also need the right climate. Even in summer, it's summer here right now, even though it doesn't look like it, it dips below freezing here. And what that means is the accumulation of snow in winter, it exceeds the snowmelt in summer. And this lets the snow pile up layer after layer every year. A cubic meter of snow weighs anywhere from 70 to 150 kilograms, about the same as 1 or 2 adult humans. But most of that volume is air. As it piles up, the collective force on all of that fluffy stuff begins a transformation. Working hard here. First, all those pretty little snowflake shapes are totally shattered into smaller grains. As they're packed together, the air pockets between them shrink. The snow becomes denser. After about 2 years, ground snow transitions into a new form called firn. Firn is an intermediate form between snow and glacier ice. It's about 2/3 the density of water, and it can take many more years for that to transition into its final form.
That final form is a big mass of dense, bubble-free ice. The ice in Mendenhall is flowing forward more than a half meter every day. Glaciers are often compared to rivers of ice, and that's not wrong. These giant solid structures behave with liquid-like tendencies.
I know what you're thinking. Ice moves because it melts, but glaciers can move without melting. Mendenhall is pretty solid. I mean, I could jump up and down on it, it doesn't deform it, but these short-term stresses don't do anything. Long-term stress, like bearing its own enormous weight, can bend and deform this ice.
What we're told makes something a solid rather than a liquid is that its atoms and molecules are so tightly bonded they can't move past each other. But this isn't the case with glacial ice. Its water molecules are arranged in an orderly pattern, but under certain conditions, they can still flow. Much of this has to do with the pressure melting point. As pressure increases, the melting point of ice decreases. When glacier ice stays close to but just below that point, it becomes malleable, much like how you can bend and deform solid metal when it's heated near its melting point.
Watch out for that. The deepest layers of a glacier are subjected to the most pressure. That's the zone of plastic flow, because the bonds between the ice crystals can be stretched rather than broken.
Here, the molecular bonds between ice crystals actually stretch and slide past each other rather than break, like how a deck of cards deforms as cards slide past each other. Magic. When the bottom of the glacier needs to move around large obstacles like boulders, even higher pressures on the uphill side cause the ice to melt, flow around the obstacle, and refreeze on the other side.
As these processes continue, the glacier creeps along, propelled by gravity, like some giant gooey conveyor belt. But up here in the top of the glacier, in this upper 150 feet or so, that's the zone of brittle flow. And the ice isn't under as much pressure, so when it's stressed, it's prone to cracking, which is why we see these beautiful crevasses and things like this.
Imagine a candy bar warping around a curved surface. The top has to curve farther and faster, so it cracks while the gooey bottom bends and stretches. Some glacier movement comes from slipping on sediment or a thin layer of water, but most glaciers not at Earth's poles move by this process of deforming. But glaciers are a product of climate, and they change with the climate. Mendenhall Glacier is currently slinking along a 13-mile journey to its lowest point, Mendenhall Lake. The terminal edge of a glacier is one of the easiest places to see its movement in action, but it's also where we can see how much things are changing. Glaciers never move backwards, and they're always melting. But when mass melts away at the bottom faster than new mass is added up top, they can recede.
It takes about 200 years for new ice to move from the ice field down here to the lake. That's a slow process, but warmer summers combined with less snowfall in winter mean that things are speeding up. The glacier is retreating faster than it's growing. Where I'm standing today was covered in ice just a few decades ago. Glaciers like this are an example of climate change that we can see in our own lifetimes. The physics of how they move is really cool, but for that to keep happening, they have to stay that way.
Thanks for watching, and stay curious.
If you want to see more of Alaska's incredible wildlife, watch Wild Alaska Live, a special 3-night live event brought to you by PBS and BBC. Check the description for more info.
How about down here? How's this? Making the YouTubes.